Arc 3 gases. What do? Everything, as long as it's welding related. We're here today to demo a Cobot, which is a Miller welding robot that you can train to replace you.
Please. You want to make sure there's not shit on the floor. If the Cobot goes over it, it'll smear it all over. Roomba jokes.
Gentle folk. Okay, pasa. Don't mind Walker. Everyone, this is Walker.
Hi, everybody.
Don't mind him.
Yeah.
Please don't.
Stop minding me. Hard at work.
Go get a sneak peek of it. Kind of low-key love that nobody asked questions anymore. I just walk back here in the back of Park 3. It's one of my favorite places ever.
Uh-huh. Oh.
Frank Ray, everyone. Say hi to the fellas and fellas.
Hello. I got a Miller hat. How about I just give you a Miller hat?
Absolutely.
Yeah.
It worked.
Oh, here we go.
Hey.
Take your pick. You guys can have the other one.
Oh, thanks, man. Look at that. That looks like a NASCAR racing team right there. Yeah, right.
Let's go. Let's put it over by that. There.
Hi, everyone. Tay here, and I'm here with David Schaefer.
Yes, David Schaefer.
We are in the Skunk Works back here in the back of Arc 3 here in Roanoke, and I just so happened to catch word yesterday that you'd be back here demoing this thing. So who are you and what is this? And then I have so many other questions.
Okay. Once again, David Schaefer, as you mentioned. I'm the product specialist for Miller Welding Automation. So it's MWA, Miller Welding Automation. We're focused on robotic welding automation systems.
Cool.
Okay. We've done systems called Performarks in the past. We actually been selling Performarks since we first opened as MWA in 2010. We just started getting in this new Cobot world. And what a Cobot is a contraction of collaborative robot.
I see.
What they first were involved in was material handling, because you want to be near a heavy part, you need some ergonomics. So you use a Cobot to lift parts up, so you didn't have to hurt yourself and break.
So it's like augmenting your strength, like
exactly.
an exosuit or something like that.
Correct. Yes.
Cool.
So then over time, people start seeing how easy it was to program these, because you can just grab the Cobot to program it where you want to lift parts up.
Right.
And say, man, let's try that in the welding.
Let's put a welder in his hand.
Exactly. So pretty much, I started seeing this about 2018 or so, 2019, coming out in the marketplace. So we kind of released our system, our Cobot, which is actually called it's branded as a co-pilot system.
Nice.
So that's what we have right here, and it's on casters, 48-inch table, as you can kind of see.
A fixture table too, which I'm super in love with here at my shop too. So this is one unit, right?
Yes.
The table.
It's got one part number to it. It's almost like ordering like a Miller-Matic or something.
That's huge.
Turnkey.
Yeah, so it's turnkey, all included. It comes with a Miller Auto Continuum welder, Tregascus torch, tabletop, and the robot here. It's a Cobot system. So once in a while I might call it a robot because I'm so used to that, but it's specifically a Cobot because you can program it by hand.
I'll call it whatever it wants to be called.
Okay.
What problem do you see this solving?
A lot of it has to do with the fact that people just can't find welders to hire anymore. So I've been hearing about this in about 2015, 2016. It went from, I got this many parts I need to weld, I need to automate, to I can't find welders, and I have no other solution besides I need to automate.
Right.
So this starts stepping into this world that still solves that same problem. Now it's then also easy to program. So it's hard to find people on the street. The people that you can get normally don't have this full CNC good programming background capability.
Yeah, welders
so
are historically like one-trick ponies, kind of.
Yes.
I get hit up all the time, kids, even young guys leaving welding school, and then they'll run a mean bead, they'll weld vertically, they'll do a 6G pipe all day long, but we run a fab shop, so it's you also got to know how to cut miters, how to run a saw, plasma. There, I do have a CNC. It helps so much if you got more than one area of skill.
Yep. And
So
traditional
it's hard to
robots,
find someone.
yeah, they take a while to program and get used to. So several days of programming. We have a full week of training in Chicago for the high-speed industrial robots. This one, honestly, I will show you. It takes about 10, 15 minutes to show somebody how to program.
Well, that's huge.
You do got to have some of the welding background to kind of understand feeds and speed and torch angles and that kind of stuff.
Right.
But somebody that's already a welder is really easy to show them how to do it. And we've been noticing that welders can pick this up so much easier than the industrial robots because, like I said, 15 minutes, it's just intuitive how to program.
Yeah. Well, we encountered it a lot too as we review new machines that have digital displays. Like the software might be so good or the menu item, but like you still need to know the terms. You know, what is post flow, pre flow, upslope, downslope? Like if you don't know what those are, then we skipped a few chapters.
Right.
Exactly. You come back but I guess on the other side of that, being that it uses that same language is helpful too, right? So like you said, a welder can pick up on this.
Yes.
Super fast.
Much quicker than the traditional, high-speed industrial robots, which require, it almost has its own, each one has its own type of interface.
Right.
So you can almost imagine going from learning what a coordinate system is and what button does what, to now just grabbing it as if you were going to weld by hand, grab it and do exactly what you do.
That's how you teach someone how to weld, right? Like, hey,
this is what you do.
Right here and go.
Pretty much.
That's cool.
All right.
That's brilliant.
And this one's actually got a built-in, it's called IntelliSet, but a built-in welding library. So all you do is tell it the thickness that you're welding, it automatically fills in the amps, volts, and travel speed for you.
Cool.
So it even takes some more of the guesswork out than you'd see traditional.
Does that mean I get to put programmer on my resume after this? Listen, I got 10 minutes. I figured it out.
How smart I am. Thanks, Miller. So yeah, how does it all work? What can you do on this? And then what do you have to go down there for anything? Like what are the major?
Yeah. Once it's set up, and if you want to show the plug-in power, but believe it or not, the Cobot itself runs off 115 volt power.
Nice.
So this is plugged in. This is the Cobot right here, 115 volts, but then you still need 3-phase for the welder. So this is the 3-phase plug in.
It's like any other CNC system where most of the table drives or the motor drives is all 110, but then you have the power source.
Yes.
Yeah, okay.
So 3-phase power, high power for the welder, 115 for the Cobot.
Nice. Cool.
So then we got the teach pennant on the front of the system here. This is basically how you kind of interface and edit the program, but every time I save a point, it adds another line of code here. These icons here, I can cut, copy, paste, and delete lines if I want to, so it's kind of real easy, icon driven, okay? We got a program screen up here, so I can go into programs, and this is where I start a new program, delete a program, and rename it.
Oh, that's nice. So if you came back to a job a month down the road, it's got the date, what you might have named it.
There's tons of programming space, tons of memory. So they say it's almost infinite, not infinite, but it's very so inexpensive. These programs are so small, you can save hundreds of types of programs. Then you got a home position, change the speed of the robot, step backwards, forwards through the program, go to a specific point in space, a specific line if you press a different line, stop the program when you're running, wire feed forward or backward, purge the gas. You could actually hear I purge the gas when I press that.
That's
Make sure you got gas flowing and it's hooked up and running. And then you can edit the program, update the position, and then a couple other things. You can do air move or weld mode here. This is insert line, but you really don't need to do that from the pennant. The whole goal and idea of this thing is to program it out here at the front of the torch in front of the Cobot and grab it and then move it around by hand. And these buttons here, which are air move and weld and then linear and circular, the same thing that would be down here, you really want to program it right from here.
Cool.
So I'll show you a little bit more.
Well, that's good too, because then you're not back and forth.
Yes, you don't want it, exactly.
Yeah.
This should once you start the program and get set up, that's almost like put that away. Spend all my time out here programming and getting the parts set up.
Nice.
Yeah.
So you've got an inside corner joint set up, little welding coupons here.
Yep.
So how would you?
And then what's also
you
nice
start?
about the system, before I start programming more, I want to show you one thing.
Sure, yeah.
Kind of move it around, kind of do coarse movements by hand.
Yeah.
But then it's got a nifty joystick in the top. Okay.
Oh, cool.
So I can move it acting guide joystick. So
That looks like one of the ones they use for 3D modeling.
Yes,
Is that basically
it's actually a
what that
3D mouse that we put on.
Cool,
Yep.
nice.
And you can use it for both translation. If you move it, you can move it in translation. Or if you want to change torque angles, it's also a rotation. Just like a 3D mouse would be. Okay, so I'm going to get back to this, and I can start a program and show you how easy it is to program this and weld it.
Yeah, so where do you
Ready?
start?
Yeah.
You clamp your piece of the table.
Yep.
First thing you do.
Yep. Start a new program.
Okay.
So we do programs, we do new, and we name it. So if you want to name it, sure.
Lift, arc.
Now do you use IntelliSet? And this is the use IntelliSet is the built-in welding library. This is a little disclaimer, just saying a couple things and little things you have to say, so continue. This is you select pull-down menu for joint type. We're going to add more joints over time.
Okay, so you've added that one in there. What is that? 8
This
inch?
is it's 3/16.
3/16.
Yeah. And then do continue.
Okay.
Now this tells you right here what it's going to recommend what you do. So this means program it at a 5/8 inch stick out. Okay. Program it at 45 degrees relative to the floor and with a 10-degree push.
Cool.
So it tells you how to program it, their recommendations. And then it gives you the recommended procedures. You can tweak them out, you just don't tweak it in this screen. So if you hit save and exit Telset, you could actually tweak it here.
Got it.
Okay. But you'll see, it's pretty.
I'd imagine you guys have done a lot of work to
pretty dang close to what it is.
Yeah, it's like that's the point. Trust the
There's
experts.
some other parts I've already done that were different than this. People brought in and we're using Telset. It's amazing how close it gets you right off the bat.
So then just hit create.
So then create, yep. Now it's already going to pre-program home position, so it's best practices to always start and end a program at the home position. So that way your torch isn't in the way and it'll be loading right into parts.
I got you.
So if I go here, I'm already on the point and just say step forward, it will step forward into the home position. Now best practice is I don't want to go right from there and program the first point, just in case, imagine if this was tilted this way, if you program to start the arc, you over here would run into the part. So best practice is to do what's what we call a pounce position, okay? So you grab the free drive button, get it out here, and it doesn't have to be perfect, just somewhere where you know you're not going to crash. So right there is good, and then I hit the top button, air move.
Air move.
And that's there's the point.
A movement in the air that has nothing to do with welding.
Correct.
Got it.
100%. And you'll see it added a line right here that says linear, which is an air move already. So
Okay.
I saved it in there.
So then you've just written go from home to there.
And it's all point to point. It doesn't remember all the stuff I do in between. It just saves where it was there and does a direct line.
So that is an interesting thing about CNC, right? Like it's specifically talking about obstacle avoidance and whatnot.
Mm-hmm.
If you've moved it, you've gone over something and then set it back down, and you say go to the previous point, it doesn't then go do that. It just goes like that.
Right, from where it's at to that.
So if you want it to go up and over, you need to program that point and then that point.
Yep, just like going over clamps avoidance. If I program from here and a point there and one there, although if I program it by hand and went over and save the point down there, it would just go from that point to that point to crash.
Right.
So you have to come up and save a point here and then save it point there.
Yeah. They're only as smart as you are. For now.
So then you'll see we get it kind of, like I said, kind of coarse in there, but then really the fine tuning is really the joystick.
Right.
The one thing you don't want to do is as you're moving this is then hit the wire and bend the wire in the part. If you bend the wire, you just lost your TCP, which stands for tool center point, the tip of the wire. So
Is that wire sticking out a certain distance already?
5/8. Yeah,
So that's
program at
okay.
5/8.
So when it says 5/8, torch distance,
You do
it's
that.
giving us that already.
Well, it doesn't give it to us. I have it pre-clipped that way.
I
So
see.
the end of the contact tip to where you're welding at pretty much.
So then when
get
you
it
see
5/8.
that, it's probably best to just go ahead and pre-clip your wire at that, so it's an indicator. Okay, cool.
So once again, instead of me moving it, I'm going to use the joystick to get it dialed in perfectly in the joint. And I like a little bit more push angle and push. You see, I can just turn it like a bottle top.
And so that rotates around like this center axis
Exactly.
kind of. Okay, cool.
So we're pretty much like right there. And now once I'm in there and I like it,
So does it push better than, I guess pushing is usually better for penetration and,
it's actually better. It's actually better for flatness.
okay.
Yes.
It's a more aesthetic weld. Yeah,
100%.
cool.
So then I do weld point, and that starts the arc there. Now, if you look at the teach pennant, you can kind of get a visual cue to say, all right, I got an amber icon that's in the beginning. That's the beginning of the
Yeah, there's sparks there now.
Yeah.
Yeah.
There you go.
Okay.
So then I'll dial it down. I'll move it down the joint, and you can either move it by hand or move it with the joystick. I like doing the joystick just so I had to keep the exact same torch angle as I'm going down the joint. I think I moved it just a hair, but it'll be all right.
Mm-hmm.
And then once I get to the end of the joint there, I just go ahead and say air point, and it's pretty much there, isn't it? Yep. So now I say air point. What that does, it tells it to stop the arc.
Ah, okay.
So some people think, I want to do another
You
weld.
just did a weld move, but AirPoint says that's at the end of the welding. Got it.
Correct.
Okay, cool.
And then you'll see the visual cue now. That's like the beginning of the
Oh.
weld. That's the end of the weld.
Nice.
Yeah. If I had a longer weld, it would put like 2 lines. It would be longer. But that just basically confirms that I just stopped the arc.
So let's say you needed to hit that and then it was a corner and then you weld around the next corner. You would hit weld point.
Yes.
If you were to keep weld.
Yes.
Okay.
Yep. And then like circular moves, you want to do a circle, it would be the same thing. You keep doing weld point all the way around.
The circle would be interesting.
Yeah. Done that before.
Yeah.
I have a
You
pre-programmed.
do it in
too.
quadrants or
You have to do it in
sub-quadrants?
iterations of 3. So what it does is when you do 3 points and you call them circular, it's going to interpolate an arc between those 3 points.
Oh,
It's
okay.
not necessarily the same radius. You can have it spiral if you want a little bit, but it will follow an arc between those 3 points.
Right.
What you also have to make sure you do is program it in iterations, multiples of 3. So 3, 6, 9, 12 points. If you don't, it doesn't know to interpolate the circle properly.
Interesting.
So if you do a circle like it's a Bosch, you actually have 6 points. 1, 2, 3, 4, 5, 6. That's iteration of 3.
Got it.
Okay.
Okay, cool.
Okay. So that finished it. Now I'm just going to kind of coarse get it out of the joint. All I have to do is do it about there, and that's fine. Air move.
Yep.
And then I want to, like I said, best practices is to start and end at home. Well, I don't know exactly where home is. There's no way I'm going to guess by hand. But what's nifty is I could just come in here and do copy, go down to the program paste, and just program the home position right there. And then if I go move forward, it goes back home.
Nice.
So I'm not guessing where that was.
Yeah. If you had a specific home.
Yeah.
Now it's ready to weld.
Yeah.
And if you had that super, like if you had another stop here to index that part, you're ready to do 1,000 of them.
Yes.
Or whatever.
And yeah, you know, you can program multiples if you want, but pretty much once it's welded, you take this off, put the next part on there, press the start button again, you're ready to go for as much parts as you need to run.
My gut is like for that, it doesn't seem like it's immediately like beneficial, but for like a more complex weldment, right? Like a circular thing or more around a corner or up and over. That's where, you know, once you do the work to program it, it's going to be the same every time, and you don't have to.
We also think about duty cycles. So manual welding, duty cycle is a percentage of arc on time. So it's a percentage. If you had the arc lit, you know, for 10 minutes straight, it's 100%.
That's the standard, right? It's the 10-minute window is sort of how they all
so people define that.
look at it, yeah.
So there's plenty of people doing plenty of studies on this, but guess what the average duty cycle that they see from manual welders out in the field?
Like the personal duty
Yes,
cycle?
manual welding duty cycle, yeah.
A minute?
Okay, but in percentage.
Oh, okay.
Yeah, say that in a percentage.
So
1 minute out of
10%.
10%. You're actually pretty good. A lot of people think it's a lot higher. It's about that 10 to 15% arc on.
Yeah.
And you think a duty
Solid.
cycle is like a specification for a welder. It is a welder machine. It's going to burn up if it's more than the 60% duty
Sure.
cycle at that certain average.
Yeah.
But the same thing will apply to manual welders. You know, what's their arc on actual time?
The person.
Yes.
Yeah.
So that's a good way to
Everybody's
get
got a duty
feedback.
cycle.
And some people are better than others. But
Yeah.
I talk to some owners and they're shocked when they actually do some measurements themselves. Like, oh yeah, we're at least 50% arc on time. And they actually did some
No.
measurements. They came like, man, you're pretty right.
Yeah.
You're closer to that 10, 15%.
Right.
And that's more about just how often the arc is lit out of whatever 10 minutes.
Yeah.
Or you can do it out of 8 hours.
Meaning you're doing something. You're repositioning, you're
Grinding,
clipping
cleaning.
wire, you're scraping the cup, whatever it is. Yeah.
Something besides welding. So in this case, it's kind of like,
Smoking in my morning.
well, think about it too. Well, this is over here welding, right? And if, let's say it was a much longer weld, you know, the operator could be over here doing something else.
Yeah.
And if he's not welding, his duty cycle isn't going down.
Yeah.
Because the arc is still lit over there.
Yeah, he's got plenty of time for Instagram.
There you go. But his duty cycle is still up there, so he won't get yelled at.
Right.
He won't
But
get in trouble for that.
Yeah.
So if we want
Light
to
it.
weld this, yeah, we're ready to go. You guys want a helmet here?
Yeah. You've got everything down here set.
Yes. Yeah, I pre-programmed the memory position to be the 045 wire AccuPulse, which is that pulse procedure we talked about for
Yeah.
90-10 gas.
So you're pulsing MIG right now.
Yes. Okay.
Be nice to have you've had a few days of spatter.
Yes.
Frickin' Lincoln school gun, man.
So what we do is turn the weld on. Go to on. If you want, I could just press the green button.
Ready?
It's up to you, man. You got the power.
Are we ready?
Oh, you
Is this on? Oh, it's done.
It is.
Even better. You'll never flash yourself. Here we go.
Good. Got it.
So it goes to that first. That is a smooth bead, man. Holy cow.
A few of those going, you probably program a song to play.
Yeah.
The ringtone.
That's pretty incredible.
Yeah.
Now, as far as like heat, you know, the heat affected zone is not huge. We have, yeah.
We usually test those with our fingers first.
I mean, she's a little warped, but that's what happens, and it might flatten back out. That's just,
Come back.
but that's part of welding. I mean, is working with the pull, you know. Yeah, we've just sort of somewhat educated ourselves on the magic of how metal moves under heat.
Yes. And you're all on one side of this part, so you're going to be distorting somehow. And you've got
100%.
full control of changing the procedure if you want. If
coming
action
back.
goes,
Yeah,
put less heat in, you can do that.
Yeah.
I seen some parts where they wanted to get it flat, and it was a part just like that. We just put a piece of wire, 045 wire, underneath it, clamp both sides down, so we kind of pre-bowed it just a
Yeah.
little bit. We just got
You
lucky
worked
with
with
it.
the pull.
It was perfect. Yeah, once we got done welding, it came back completely flat.
Yeah.
But that's one way to do it. You just really got to pre-bend if you're going to weld on one side of it.
That's pretty awesome, man.
Yeah.
Like
You
it's,
saw how fast it was and how easy it was to program.
Yeah.
I mean, it's really within 15 minutes we're teaching
once you get your
program.
muscle memory trained, you're like, a new part's not going to throw you off like it would normally in a traditional programming environment. You know, you're just like, oh, cool, new part. I just aim it in a different place.
Totally intuitive.
Yeah.
And the big thing is you could have some idiot standing here and just repositioning and refixturing every
Yeah.
time and doing the same, bringing out expert welds.
Well, yeah.
Yeah.
So, I mean, my idea is if you got somebody who's not like a professional welder, but can at least learn how to follow instructions.
Yeah.
Much
It's
lower
still-
entry.
all you gotta do is now, just teach a guy to come over here. If we had one more stop, it's not have this fixture set up to do that perfect, but pretty much you can imagine just one more stop behind it. All you have to come down there, do that, load
Yep.
it, and then just come in and press a button.
Flip it and go.
You're ready to go.
Can I move the arm around?
Yeah.
I want to see what it feels like.
So yeah, and usually we have people, there you go. I got it.
Yeah, where it's recessed, it's almost just like
Just
bringing
make it
it,
flush.
Make it flush.
Yeah.
Exactly.
and then it moves.
And it sort of helps you move a little bit. You don't have to hold the whole weight. It's sort of like,
Yeah, release the brakes and then kind of holds itself steady for you to be able to move it around.
that's hard flank or angle. And then to move it planar, flat. So like pushing that puck flat moves it flat. And
Yeah,
tilting
it
the
is.
top is the angle. I'm sold. I'll take 3.
Great. That's a verbal
Yes, I'm
contract
fired.
right there. I got that on video.
delete the footage.
No, your new job is Cobot manager.
I got a circle pre-programmed. You want me to run a circle program? I can.
Oh, that'd be
Yeah.
cool. That'd be really neat to see.
Just to watch it move,
Just to watch it.
Yeah.
Yeah.
That's what's impressive. I mean, that's
Well,
impressive.
because
but
The
the whole,
articulation.
when it's
Oh, yeah.
Yeah.
well,
We're
anyone,
like skipping around stuff and welding it.
well, so Aaron used to build super high-end bike frames, and like so, like the maintaining arc
was
angle,
Super
the TIG
important.
whip, yeah.
So this will just run through a circle. I had a part program there before. It'll just kind of show you
Oh yeah.
how it interpolates a circle, no problem. And you notice how we wrap it a little bit. For a 360-degree weld, you kind of pre-wrap the torch a little bit and then unwind it to go
Yeah,
360
yeah.
down.
Sort of like your wrist, like you have the stars here, and then
And then here's what it looks like in the teach, and then see how it's got a long. There's the arc start, and then every iteration that keeps the arc lit is kind of straight lines
every
until
one
we
of those
finish.
points is the next line.
Yeah. Between linear and circular moves, you can program just about anything.
I didn't
Every
hear
part is different
once.
geometry.
Yeah.
Didn't hear it curse once. Yeah. Damn it. It doesn't have a drinking problem.
Yet.
Yeah. You come in, your robot's like, you're welding today.
Cobot.
Cobot. Boy,
Very
cool.
cool.
Do you have any, so where can people learn more about it? Obviously from ARC 3. and
Yeah,
Builder,
Arc
but,
3.
like,
Look, we're here in Roanoke, Virginia right now, so Frank can be your assistance of helping you kind of get quotes on, get more information. Our main Miller Welding automation number, you feel free to call us up there too, 630-653-6819. You can help with
there.
that. We'll get you hooked up. We've got representatives across the whole country to help you out. So.
About to say, if someone watching works at a shop, that, and they might want to show this or get their boss or whoever to maybe get a demo, is that a thing they can?
Yeah.
Yeah.
Well,
arrange?
one thing that's great is we got videos on this. They're both training, but they also work as demo videos. So if you go to millerwelds.com and you go to click over automate equipment, then automation, you kind of get to our landing page and then see the Cobot demos and videos there.
Cool.
It's amazing.
Is this made in Appleton?
Yes, we actually build the whole system in Appleton. Yes, sir.
Love this.
Used to have family now. Great cheese.
Yeah.
And I don't know if you mentioned this or not, but Miller handles the whole system.
Yeah.
You guys designed the software.
Yeah, we built this, we
It's all
designed and wrote the
yours.
software from the ground up, the arc welding software. So it's, like I said, the start kind of material handling, Cobots is where they started. We were writing our own software to be welding software from the ground up, so we don't have any superfluous commands.
All that bloodware and stuff is gone.
All that stuff.
Yeah. Cool, man. Well, thank you so much for taking
Yeah.
time out of your day. I know you were here already, but thanks for staying late for us.
Yeah. So what'd you read?
This is great.
Go buy Cobot. I sure do.
Would you want to try that again? Or
I don't want to try that again. Thanks for watching. Like, subscribe, and go patronize these gentlemen's companies. ARC 3, all your East Coast welding supplies, and we all know Miller's the best. So do those things. Corporate shilling. All right, look, the robot arm is awesome. The Cobot from Miller is a cool piece of tech. But before everyone starts freaking out in the comments going, it's gonna take our jobs, it'll never replace us. It's like, well, those were two different points, but you're right. Like, I think these things are a long way from replacing welders, because it's like, the robot arm has like a 5-year-old's brain. It can do what you show it to do.
I think that's the key takeaway, is that you still have to do the thinking for it.
Yeah, you still have to know what you want to weld, how you want to weld it, and have to like you have to still be a welder. This is sort of just a third arm. Like you have a bunch of parts to make. You can teach it, set it free, go do some other things. But when it's done, it's like a 3D printer or an actual printer. Like when it's done doing the task that you've given it to do, it's gonna sit there and do nothing until you give it more instructions. So they don't have emotions. They don't smoke cigarettes. They don't get hurt. They don't need workers' comp. You know, they don't need paid time off. They don't have vacations. Their wives aren't gonna get pregnant. Their kids aren't gonna have, they don't have kids.
Yet.
So, there's two, those arguments are made by people that run businesses, specifically businesses with lots of employees, but it's also a callous and cold way to go about it. Like, well, freaking meatbag human employees are high maintenance. Let's get rid of that liability and pay some robot to do their job. If you work at a monotonous, repetitive welding, production welding place, I mean, I'm sorry to say if this is the first time hearing it, but yes, robots will be replacing you at some point. But, for places like us here at Lift Arc and, custom shops, prototype shops, high-end shops, people that do sculpture work, custom railings, furniture, all that sort of thing, I think we're gonna be fine for quite a while. So it's a cool piece of tech. It has come a long way. I think this is the first robot that has severely flattened the learning curve. And it's under 6 figures, which is, I mean, if you think about what welders make, it'll pay for itself in a year if you're doing repetitive fixturing and whatnot. So
You said it was 95 grand?
it was $95,000 for this thing. So, which is nice. I mean, if you have the kind of shop where you can work this thing every day, like it's probably meant to be worked, I think it's gonna pay for itself rather quickly and be an asset for your shop. But as far as the more grand discussion about robots replacing welders' jobs, I would say my official answer is, it depends. It's not gonna be for, until the robot can, until you can put a fixture on a table and the robot can sort of automatically figure out how and how to weld it instead of you having to walk it through. Because it's still dumb. It's not doing there's no neural network, there's no AI, there's no machine learning going on. It is memorizing the moves that you teach it, and it is just doing those moves. It would do those moves whether or not the part was on the table. It's just locating itself in 3D space and repeating what you show it. So it's not that smart. So until the robot can do some of its own thinking and planning and adapting, you don't have much to worry about.
Yeah.
We don't really have a use for something like that here, per se. Maybe you do. Thank you all for watching. If you are in the vicinity of an Arc 3, I highly recommend you looking towards them for welding supplies, welding gases, safety equipment, welders themselves, or any other metalworking tools. They supported me for 15 years, long before the YouTube channel. So go check them out. They're great people to work with. Other than that, subscribe, like, comment. We're lower on our long sleeve t-shirts, but winter's coming up, so make sure you snag a t-shirt for yourself. We have chosen a winner for the free version of the Arc Captain Welder giveaway. We are waiting for them to, we're connecting the dots on the back end, but they have responded to our emails. But the one that we are giving away, every dollar spent on liftarcstudios.com gives you 1 entry toward that one. We will sign it, we will throw some stuff in the box for you, and we will ship it to you directly. That's a lower 48 states only kind of thing. But anyway, this doesn't tell me the day. It's the 23rd, I think, so 8 days left. 7 days if you're watching this on Thursday, and 6 days if you're watching this on Friday.
Yeah. There you go.
You like that fast math?
Yeah, fast math.
Thank you, love you, bye. Mwah.
Wow.